Okay, so we'll go ahead and get started. My name is Dr. Mike Smith. Dr. Mike is what most people call me. I'm the senior scientist and the national spokesperson for Life Extension. Everybody familiar with Life Extension? Okay, good, because this has been my little, I get 1 minute just to talk about Life Extension real quick. We are the world's largest nonprofit health organization in terms of anti-aging and supplement research. We're getting close to $200 million in the last 10 years on proving to the world that supplements work. We were the first company to bring CoQ10 to the market here in the United States, melatonin, DHEA. I always miss it. We were the first organization to recommend a baby aspirin for heart patients. We actually had to fight the FDA for that. We've actually been rated by the FDA. So we've been around since 1981. There's our buyer club side, which is the products that we sell, but all of that is based on the science we do at the foundation. So there's kind of like two halves of Life Extension. And we really pride ourselves in being kind of science nerds. We really enjoy the rigorous science. And then my job is to come here and turn all of that science into something that's more practical for all of us every day. All right? Whoops, I went too far. All right? So that's Life Extension. Let's go ahead. Here's one of the things we want to talk about. There's a lot of products like that on the market. Energy drinks, right? I need more energy. I crash at 3 o'clock. I need my caffeine, whatever it is, right? As a matter of fact, what's in most of those products? Still a lot of caffeine, right? Now, the companies that make these products are smart, though. They know what are the key ingredients to include, even if it's a little bit, so they can say it contains CoQ10, or it contains taurine, or any of these, it contains B vitamins. But if you actually look at the amount of those nutrients in those products, pretty much nil. It's just enough for them to be able to claim it on a label, and claim it on the front label, really, in many cases. So, of course, lots of us do this, right? We got to get a lot of energy. We got to wake up. We drink lots of coffee, right? And then what happens a couple hours later? We're done. We're out for the count until we get our next energy shot, right? Well, one of the greatest things about natural medicine, by the way, I am a medical doctor. I was a radiologist. I didn't like that. I went in internal medicine. I really didn't enjoy that. But I found out I really didn't like the everyday practice, so I became a teacher. I've worked for the pharmaceutical industry. Boo. I did that for many years. Realized that a lot of the drugs and procedures that conventional medicine uses, they're just Band-Aids. And that's what a lot of these things are. They're just kind of Band-Aids, aren't they? You feel a little low, you don't have a lot of energy, so what do? You take a quick shot, woohoo, and you're out. Right? It's just a Band-Aid for a second. What really interested me about natural medicine, which happened about 10 years ago, I found out that there were more solutions in natural medicine versus conventional medicine. And so what we're going to talk about today is really the solution for low energy, not just a Band-Aid. Sound good? Okay. So that's what we don't want right after we take our energy shot. Have any of you done things like the 5-hour energy? Or Monster drinks? You guys haven't done stuff like that? Coffee drinkers? Listen, there's nothing wrong. I drink coffee. There's nothing wrong with coffee. I like my coffee. I'm not saying don't stop. I'm not here to tell you to not drink coffee. But I am going to tell you that there's a better way to have lasting, sustaining energy, okay? So here's what we're going to do. Here's how we do it. We need real energy. Real energy comes from a molecule in your body called ATP. Who's heard of that? ATP. Who knows what it stands for? Adenosine triphosphate. It's a fancy chemical that when you take adenosine triphosphate, and you break the bonds in the molecule, it releases energy that the cell can use to do its job, to function. Okay? So if you want to have a nice energy boost that's lasting and safe and that's real, what we need is not stimulants. Instead, what we need is more ATP. When you eat food, food is turned in eventually into ATP. So what we need to do is we need to have better pathways to making ATP if we want to feel better. We want to have more energy. This is the safe way to have lasting energy. Now I'm gonna go over a few nutrients. I bet many of the nutrients I covered tonight are brand new to you. Okay, brand new nutrients. But let's never forget something. There are 4, at least this is my opinion, okay, 4 foundational supplements that I think everybody should be taking. Okay? The first one is a really good multivitamin with a nice balanced B. Who takes a multivitamin in here? You can raise your hand. Well, it's a little low. So 1, 2, you two, both of you. So that's 4, and then 5 of you don't. Well, she didn't count. 4 of you don't. Why don't you take a multivitamin? Do you mind if I ask why you don't take a multivitamin? Okay, not once. But you do take some vitamins, some extra minerals. Yeah. Now but you did say something interesting, because I've said it before too. Well, I eat healthy, right? I should be getting my vitamins and minerals from my food, and you should. But there's a problem with that. What's the problem with our food chain in the United States? What's the problem with our soil? Yeah, they're poor, they're depleted. A really famous nutritionist once told me that a tomato today isn't close to what a tomato was 100 years ago. Doesn't taste the same. It's missing lycopene. It's missing antioxidants. Magnesium. Okay, is blood pressure a problem? High blood pressure a problem in this country? Yes. Is high blood sugar a problem in this country? Yes. Do people have muscle cramps in this country, like restless leg syndrome? Yes. Do people get anxious in this country? Do you know those 4 things could be all linked to a magnesium deficiency? And what's one of the greatest minerals missing from our soils? Magnesium. Yeah. Hold on. Huh? I'm sorry? Yeah. That's good. That's I like that. That's fine. It gives you the magnesium that you're missing. Point I'm making is because we live in a world today with stress, poor soils, I really still think a multivitamin is important. Or if you want to split it up, that's fine, but we got to make sure we're getting optimal levels of these vitamins and minerals. Ubiquinol CoQ10. Do people take that? Who takes CoQ10? Okay, that's a great nutrient for energy. I'm not really going to talk about CoQ10 tonight. I'm talking about some different ones, but I think CoQ10 should be something everybody should at least look into a little bit and read about. Number 3, probiotics. All right, remember, you're only as healthy as your gut. And probiotics improve gut health, and that's going to have an effect all over your body. As a matter of fact, you guys know we're learning that probiotics can be good for your brain, your heart, even mood. We even came out with a product that's a probiotic that improves mood. So probiotics are very important to your body. And lastly, the omega-3 fats, the omega-3 oils. Whether you get it from fish, or you get it from algae, or you get it from krill, omega-3 is very, very important, okay? So those foundational products, key, okay. But we're going to talk about improving energy, and we're going to talk about doing it by actually solving the problem, which is low ATP production. We've got to boost ATP up. That's the energy molecule. You remember that slide? We've got to boost ATP. And here's how we're going to do it. There's 2 steps. Okay. First step, it says improving the infrastructure. Now, what I mean by that, most of the energy that is made in the body, the ATP, is made inside the cell's powerhouse. What is that? Do you guys know what the cell's powerhouse is? The mitochondria, right? Have you guys heard that word before? This is actually a picture of a mitochondria. So you have a bunch of those inside your cells. And inside the mitochondria, all the food is turned into ATP. So we got to make sure that we have healthy mitochondria. And the pathways that the mitochondria use to make energy, they have to be healthy as well. So that's what I mean by improving the infrastructure, the powerhouses. That's the first step. The second thing is then we're going to improve output, which is energy production. So we put in the food and we output the energy, ATP. But before we do that, we got to make sure the infrastructure is healthy. So that's what we're going to talk about first. So let's look at step number 1 in improving the infrastructure. What's really cool about this stuff, you guys, there are I'm going to present to you nutrients and some ideas that many doctors don't even know about. That's how cutting edge this information actually is. So let's talk about a nutrient called pyrroloquinoline quinone. We abbreviate it PQQ. That's easier, right? So we'll just call it PQQ moving forward. Pyrroloquinoline quinone, PQQ. PQQ helps your cell make brand new mitochondria. So you're going to build brand new powerhouses with PQQ. So this is, again, the picture of the mitochondria. Food sources move into the mitochondria. Those food sources are then sent down different pathways, and at the end of it is ATP production. So we need healthy, brand new mitochondria. Most people, based on the research, by the time you're around 50 or 60, you've lost about half of your mitochondrial mass throughout your body. And one of the leading theories of aging, really one of the earliest theories of aging, was loss of energy production. And we now know that's linked to mitochondrial loss. It's called mitochondrial decay. So we have now a nutrient that can actually generate mitochondria, and that nutrient is called PQQ. PQQ was discovered in 1979, or at least that's the first year that it was coined PQQ. Okay? It has a lot of jobs in the body. Now, first of all, it is an essential nutrient. Now, what in nutrition, what is an essential nutrient? Is an essential nutrient one I get from food or not from food? An essential nutrient is one that you have to get from food because your body doesn't make it. So the word essential in nutrition doesn't mean important, really. It means you have to get it from food. Vitamin C is your classic... that didn't work. Vitamin C is your classic... hold on one sec. Sorry about that. Is your classic essential vitamin. Your body doesn't make vitamin C, so you have to get it from oranges or whatever. PQQ is not made by your body. So it's an essential nutrient. One of the best food sources of PQQ is kiwi fruit. Unfortunately, the amount of PQQ in kiwi is almost immeasurable. It's very, very, very low. Now, when you're younger, like one of our audience members here, her biomass of mitochondria is so high, the fact that she's not getting a lot of PQQ from her diet doesn't really matter yet. She has plenty of mitochondria in her body. We want some of that, right? Give us some of your mitochondria. But as she goes into her 20s and 30s and 40s, what's happening to that mitochondrial biomass? It's dropping, and then it becomes important to get PQQ from your food. But the problem is there's not a lot of food sources high in PQQ. What we've really learned here is we really need a supplement of PQQ if we want to make new mitochondria. Well, how does it do it? How does PQQ make new mitochondria? Well, we've learned that PQQ is something called a transcription factor. All that means is PQQ, when it goes into your body and gets into the cell, it can actually go to the DNA and it can talk to the genes that are responsible for making mitochondria. It can turn them on. We call that expressing them. So PQQ expresses the genes that make mitochondria. That field of study right there, when a nutrient can influence your genes, turning them on or off in positive ways, that's called epigenetics. Epi meaning above the genes, or it's also called nutrigenomics, nutrients that affect the genome. Fascinating field of study. Have you ever been told there's nothing you can do about things because your family is what is your family, your genes are your genes? Couldn't be further from the truth. Your DNA, what we're learning, is really just a blueprint. It does establish who you are in many ways, but you can actually influence the building of that blueprint with certain foods. Foods can affect your genes. And that's what we have here with PQQ. So if you do eat a lot of kiwi and you get some PQQ, you will turn on a lot of the genes that make mitochondria. How much kiwi do you think you'd have to eat? More than you probably could in a day. That's why the supplement becomes important. This is a really nice slide. Now I have to explain it for a sec, so it's pretty straightforward. This is an image of a rat muscle, and it's using an electron microscope. So that's like amplifying, like huge, right? Okay. On this side, like right here, is this rat. Now this was an old rat. And as an old rat, he was not able, or she, I don't know what the gender was, she was not able to do like the maze very well or to swim. You know, they do these tests with the rats. And the rat just wasn't able to perform this. The rat was kind of overweight. So what you see here is muscle. Here's the muscle striation. So this is like maybe a muscle in one of the limbs. Okay? And the muscle cell itself lives in these ridges. And that's where you should see a lot of mitochondria. What I'm pointing to is these muscle cells, before PQQ was given, there's hardly any mitochondria. So this poor old rat is just starting to, unfortunately, die. There's just no mitochondria. There's no more energy production. He's or she is coming to the end of her life. So what do? They gave PQQ for only a couple of weeks. And they redid another biopsy of the muscle, put it underneath an electron microscope again, and look what happened. See these big like images here, these big circles? That's brand new mitochondria. So this rat, after taking PQQ, made new mitochondria. This rat was now able to do the swim test, the mazes. The rat lost some weight. That's all simply because the rat is now making more ATP. This rat has improved one of the key infrastructures, the mitochondria. Good, everybody got that? So that's PQQ. That's step number one. Step number two in the infrastructure is we have to improve the assembly lines. And that is with, and what's important to this is a structure called a ribosome. Has anybody taken any biology here before? You know what a ribosome is? Ribosome is an important structure in making proteins in the body. So let me explain it this way. These chairs up front, right here, these represent proteins that are very important in making energy. So on this side, this is where sugar comes in, like food sources. Come in, and they start on this chair number one, which is a protein. There's a chemical reaction that happens that then sends the metabolites of that to the next chair, and to the next one, and the next one, and then eventually you end up with ATP. So it's a long series of reactions to turn, say, sugar into ATP. And all along the way is this important assembly line of proteins. Now, as you get older, what do you think happens to these proteins in the assembly line? They go away. They die off. So you start losing the protein. And now you have this broken assembly line, which makes it really hard for the cell to make ATP. And one of the reasons you lose these proteins is you don't have any more ribosomes. Ribosomes are cellular machines that produce proteins, important biological molecules. Let me show you it on this picture here. This right here is the ribosome. There's two parts. There's this subunit and this subunit. Okay? The DNA is transcribed into something called RNA. The RNA, which is still genetic material, feeds into the ribosome, and out on the top shoots the protein. That protein then feeds into the mitochondria and becomes part of this assembly line. As you get older, you don't have any more, well, you don't have a lot of ribosomes. They break down, which means the proteins break down and are missing. Everybody follow that? So what we want to do is I want to strengthen, not only give you brand new mitochondria with PQQ, I want to strengthen this assembly line by making more protein and putting them back in this assembly line. See, I'm rebuilding it, right? So in order to do that, I need to give you more ribosomes. I need to give you more ribosomes. And to do that, we've discovered this. French oak tree extract. French oak tree extract has a compound in it called roburins. Roburins are a compound found in the French oak extract. Evidence suggests that roburins, when you ingest them, increase ribosomal biogenesis. That's just a fancy way of saying you make more ribosomes. So when you take this compound, French oak tree extract, that has a high level of the roburins in it, you're going to make more ribosomes, you're going to make more protein, and you're going to make a nice assembly line in your brand new mitochondria because you also take PQQ. Now you have a nice brand new mitochondria that has a nice assembly line of proteins that ends up with awesome high level of ATP production. Everybody follow? This is how you solve the problem of low energy. It's not about caffeine. It's about understanding how the cell makes energy and what's needed to make it. So let me show you the research results when you ingest in a supplement roburins. In a human study, researchers found that roburins could reduce weakness and exhaustion by 18%. You have a 44% reduction in unrefreshing sleep, 33% reduction in head discomfort. What is that? Headache, yeah. We have to say it that way. Thank the FDA. It is what it is. 51% reduction in joint discomfort and a 63% reduction in muscle discomfort. Let me ask you something. Why? Okay, so I help you guys make new mitochondria. That's great. I help you make more ribosomes so you can have proteins to have a nice assembly line, so you make more ATP. How come, why does making more ATP help my joints? How does it decrease my headaches? Because if you have more energy for the cell to function, then the body can heal. The body can function normally. So every part of your body gets better. You sleep better, your joints feel better, your bones get better, your heart gets better. Everything improves. That's why this is so important. All right, so that's the infrastructure. We got PQQ for mitochondria, and we have the roburins for the assembly line. Everybody good? Are there any questions on those two? Everybody good? Not losing anybody? Okay. The next thing we want to do is we want to improve output now. Let's actually make more ATP. We're going to do that by activating what's called the master control switch. So let's go back to the assembly line. Now the master control switch is called AMPK. It stands for adenosine monophosphate protein kinase. Don't worry about that big name. It's just AMPK. Now, let's go back to this assembly line. So here's my assembly line, right? So I have assembly line inside a brand new mitochondria that's going to make ATP, right? Now, just like in an actual factory, just because I have an assembly line, I still have to do what? I have to switch a switch, or turn a switch that turns on the assembly line, right? That's what AMPK is. It's the switch that activates that first reaction that then sends the sugar or the food sources all the way down to make ATP. So not only do I need the powerhouse, not only do I need the assembly line, I have to actually come back here and I have to turn it on. Doo-doo. And now it starts to crank out the ATP. That's what AMPK does. It's an enzyme that acts as that switch. Guess what happens to AMPK activation as you get older? It turns off. The switch turns off. We have less active assembly lines as we get older. Why? Well, there's probably a lot of reasons for that. Poor diet, chronic inflammation, stress. I mean, these kind of things really affect it. I mean, we already know that. You guys know chronic stress can decrease longevity, right? We know that. Well, what we're learning is it probably is acting through these energy pathways. When you're too stressed out chronically, you turn off these switches. You don't make energy. If your cell can't make energy, it can't function. What happens to you eventually? So that's the link between stress and, say, premature death. It could be all focused on these assembly lines of making energy. So what we want to do is we want to reactivate AMPK. We want to be able to come in here and turn this switch on. When we do that, when we turn on AMPK, you're going to turn on pathways that generate ATP. That makes sense, right? I turn the switch on, the food sources come down, and I end up with what? ATP. So when I activate AMPK, I do things that create energy, and I turn off things that use energy. This is important because instead of making cholesterol, instead of storing fat, I burn it. Instead of having sugar issues, I burn it. So you can see the implication here. Activating AMPK can make sugar better, fat better, right? You guys see the implication of that. So let me show you the first study we introduced. There's two extracts we use to activate AMPK, and the first one is related to cucumber. It's called Gynostenum pentaphyllum. Anybody ever hear of that one? Gynostenum pentaphyllum activates AMPK. This was a really cool study. Does it make sense, everything you know about AMPK? Remember, if I turn on AMPK, I burn more food sources to make more energy, ATP. Come down the assembly line, right? Everybody got that? If I'm burning more sugar and burning more fat, does it make sense that one of the first studies showed a significant amount of weight loss with AMPK activation? Does that make sense? It should. Look what happened. 80 obese people for 12 weeks took Gynostenum pentaphyllum, they activated AMPK, they lost over 3 inches squared around their body. Internal fat that we call visceral fat went down, and their waist circumference went down. That's really important. By the way, you know, anytime you see a weight loss study and there's evidence that the waist size came down, that's really important because it's not the overall weight you have that puts your heart and brain at risk. It's really your waist size. Waist circumference, the higher it is a cardiovascular disease risk factor. So when as a medical doctor, when I see something decrease waist circumference, I pay attention to that. That's really important. So Gynostenum pentaphyllum, through this weight loss study, was secondary proof that it was activating AMPK. Now we've combined it with something called rose canina. This is also known as dog rose. It's when the fruit buds, it's called rose hips. You guys familiar with rose hips? Now, bless you. Now rose hips, that's not what we're using here. By the way, what was the first culture to write down that they used rose hips? What was the first? Say? No, on the other side, Egyptians. Yeah, they apparently used rose hips on their face, and it helped. Why would that help? What's in rose hips? Vitamin C. Vitamin C is good for skin because it makes collagen. So they were right. I don't think they knew that vitamin C made collagen, but they knew when they rubbed this on their face, it looked better. So that was one of the first documented uses of rose hips. But we're not using the rose hip part. We're using, I think, the stem and the leaf to actually pull out a very key compound called trans-telluroside. That's important. There's two overall types of companies in this industry. On one hand, you have whole food-based companies that would use like the whole rose canina in a product. And then there's companies like Life Extension. We like to know what's the actual compound in the plant that's giving me my benefit. And that's just our philosophy. It's how we approach natural medicine. And it turns out in rose hips, rose canina, is this flavonoid called trans-telluroside. It's just, flavonoid's a fancy name for antioxidant. And it's this antioxidant that actually activates AMPK. So we have this study here. If you activate AMPK and you're taking in sugar, going down the assembly line and making more ATP, does it make sense that your blood sugar levels will drop a little bit? Think about it. If I'm taking sugar from my food source and I'm bringing them into the assembly line and burning them, that's how we usually say it, burning the sugar for energy to make ATP, does it make sense that my blood sugar levels can drop a little bit? Yeah, and this was a study that proved it. Here you have a rat study. You had some rats that weren't giving anything. That's the black line. Their blood sugar levels didn't really drop. This one right here, this 23% drop, was a drug called Metformin. That's a diabetic drug. Metformin decreases blood sugar levels for diabetics. It does it through activating AMPK. So we actually have a pharmaceutical drug that's an AMPK activator. Rose canina with the trans-telluroside decreased the blood glucose by 30%. It actually beat, in this case, the prescription drug Metformin. Now, I'm not telling you that trans-telluroside is superior to Metformin. I can't say that. That's a different type of study, but this is definitely interesting to us. So this is kind of, again, like secondary proof that trans-telluroside is coming over here. It's turning on the AMPK switch, activating this assembly line, and so instead of building up sugar and causing high blood sugar, I'm actually bringing it down the assembly line and I'm burning it to make ATP. Everybody see that? That's trans-telluroside. So here's what we have. If this is research-supported benefits of activating AMPK, whether you do that with Metformin or Gynostenum pentaphyllum or Rose canina, here's the benefits. You could decrease blood sugar. You can lose some weight, ease chronic inflammation. You can even decrease cancer risk. You can improve metabolism. Why? Because I'm activating the assembly line that makes ATP. Okay? All right. Next, number 2 for output is igniting energy production. So let's go back to the assembly line. So here's my assembly line, guys, right? Now, we already made new mitochondria. We already have new proteins for the assembly line. I'm turning it on. That's the AMPK activation. But that's not enough. I still have to have a mechanism that takes the sugar, the food, and actually puts it on the assembly line. It's kind of like in a factory, right? If you have an assembly line and stuff, there usually is one person that kind of begins the process. Not only do they turn it on, whatever stuff you're going to build, they put the initial material on the assembly line, right? That's what we have next. There's a compound called nicotinamide adenine dinucleotide. That's the compound that takes the sugar and puts it on the assembly line. Very important step in making energy. So if you look at it here, this is your cell. There's your glucose. That's your sugar that comes from the pasta you just ate or the flatbread pizza you just had or whatever you enjoy. Dare I say the donut? I don't know. You guys like to we're more healthier than that, right? But anyways, that food source is eventually broken down to sugar, glucose. That feeds into the cell. That sugar now has to be put on the assembly line. And that's what NAD does. NAD takes that sugar, puts it on the assembly line so that I can start making ATP out of it. Everybody follow that? So we need, not only do we need new mitochondria, infrastructure, not only do we need good assembly lines, those are the ribosomes, infrastructure, not only do we need to turn the switch on, AMPK, we also need that compound that puts the sugar on the assembly line. Everybody follow that? Mitochondria, ribosomes, turn on the assembly line and put the sugar on it. It's kind of like 4 steps. That's what NAD does. It puts the sugar on the assembly line. If you have low levels of NAD, these are the research-supported consequences of not being able to put the sugar. If I can't put the sugar or whatever energy source I want to use on the assembly line, what happens ultimately to ATP production? It goes down, right? If I can't make ATP, cell energy goes down, the cell begins to dysfunction, and you get things like neurodegeneration, nerve disease. You get problems with inflammation. You get problems with fat metabolism. You even can lose muscle mass and muscle strength. Does it make sense? Because you're not making energy. That's how important ATP is to overall health. I'm going to skip that slide. So we're going to use, in order to increase NAD levels in the cell, we're using a compound that's related to vitamin B3. What's vitamin B3? Niacin. Anybody ever try niacin? Did you like it? Yeah, it's pretty strong. Did you? Scary, yeah, it's called flushing. Good news, it's not dangerous. It does freak some people out. Believe it or not, there's some people that like it. I don't know. They feel good. I have a friend that works out with niacin. He likes that flush, whatever. So niacin is vitamin B3. Nicotinamide riboside is the compound we're using to increase NAD levels. It's related to niacin. Niacin actually will increase NAD levels. It'll increase the process of putting sugar on the assembly line. The problem with niacin, the flush, people can't do a high dose, and it takes like 4 steps to do this. Nicotinamide riboside, what we're using at Life Extension, doesn't cause a flush and only takes 1 step to make NAD. So it's a better alternative to niacin for boosting NAD levels. So let's just review where we've been. We're talking about improving energy levels for Americans because we live crazy lives. We're stressed out, right? We need all these caffeine shots and monster drinks and 5 energy shots and what have you. Those are just Band-Aids. Instead, there's a better way to have energy every day consistently that lasts without crash. But to get there, that means you have to, number 1, improve infrastructure, right? So that means you need more mitochondria. That's the PQQ. You need more of the assembly line. That's the ribosomes, the French oak tree extract, robulins, right? And then number 2, you need better output. You got to turn on the assembly line, AMPK activation, and then you need to put the sugar on the assembly line. That's nicotinamide riboside. That's a good way to improve infrastructure and output. It's an actual solution to the problem, ATP production. Now, what about if you just need a quick shot of energy? There is a safe way to get a quick shot of energy without stimulating your heart and your brain. That's really the problem with the monster drinks, right? Stimulants. You feel energized because it revs up your cardiovascular system. It revs up certain neurotransmitters in your brains, or your, right? Well, we don't want that. But sometimes we do just need to have quick energy. Well, there's a combination of 2 nutrients that can give you a quick shot of ATP production. And that's a better, safer way to feel energized. The combination is Cordyceps and ginseng. Anybody hear of Cordyceps before? Yeah? They're kind of weird, right? Cordyceps are when a fungus attaches to something like a worm and starts to grow in that worm. In some cases, the fungus can attach to ants and grows on the ants. It's a parasitic fungus. So cordyceps, here's a picture of it. Here's the worm. The fungus attaches to it. It grows off the worm. In the early part of that process, when the fungus just begins to grow, if you captured it right at that moment, there's a lot of really good nutrients that can actually boost ATP production. And so when you take that cordyceps and combine it with ginseng, you can get a quick shot of ATP. Notice it's not a shot like caffeine, which is a stimulant. It's true ATP production. Here was a study. This is a nice study. This was using cordyceps. 20 healthy adults in their 50s to 70s. And that's important because a lot of energy studies, exercise performance studies are done on younger people. So it's kind of hard to know really what the results are because they're young. And so when you tell me a 20-year-old did a cordyceps and they had more energy, well, I don't know what that really means. He's 20 years old. I mean, they always have energy, right? It's hard to really tell. But in this case, this was an older population. They were given cordyceps versus placebo. And here's what's important. When you do exercise studies, you can measure all kinds of things like muscle recovery, muscle soreness. You can actually measure how they were breathing, lung volume as they're exercising. They looked at a whole bunch of exercise performance measurements, and the cordyceps group had all of them, all measures of exercise performance improved. So they breathed better. They had less muscle issues afterwards. They went through the exercise routine better. All of these things improved in the group taking the cordyceps. Why? They had a quick shot of ATP production. When you combine it with ginseng, which is really good for energy itself, ginseng's been linked to ATP production, so we're combining the two because this gives you good, quick ATP production, and the ginseng helps to make it last a little bit as well. We think that's going to help with stamina, energy, mental acuity. It's better than the caffeine shots. So, we're going to improve energy first by improving infrastructure, more powerhouses with PQQ, and more assembly lines using the French oak tree extract. We're going to have better output by activating the assembly line, AMPK activators. We're going to ignite the energy production with the nicotinamide ribosides that puts the sugar on the assembly line. And then lastly, if you need that quick shot, we have cordyceps and ginseng combinations. This, what you're looking at, this slide demonstrates natural medicine's solution to low energy, which is making real energy ATP, not a stimulant. Any questions? That was a lot of information. You guys just covered a lot of stuff that doctors don't even know about. So we can open up to questions right now. Can I turn the lights on? Is that okay? Lights on? All right. So what do you guys think? Great question. Yeah. Yeah. Okay. So, well, I'm going to answer that in two ways. Let me just turn this off.